So sometimes when we're working problems, it's necessary to have a three-part inequality. What that's going to look like is something like this. We have 3 is less than x plus 2 is less than 8. The two inequality signs creates 3 different parts. That's why it's called a three-part inequality. Okay, so the order is important. The order that you write your parts in, it has to make sense based on the inequality symbols. 3 is less than x plus 2 is less than 8. This is in the correct order because 3 is less than 8. You couldn't have those switched and say 8 is less than 3. That's not true. Okay, so the numbers within the statement should be in the same order that they appear on a number line. So 3 comes before 8 on a number line. Okay, we're going to just dive right into some examples. Example 1. Solve -2 is less than or equal to -3k minus 1 is less than or equal to 5. So the way that we solve a three-part inequality is really similar to how we would solve a normal inequality. It's just that anything we do, we have to do to all 3 parts. So focus on the center part, the part that has the variable, in this case k. And we want to still work to get that variable by itself. So we want to undo what's being done to this variable. Right now we've got it having 1 subtracted from it. So to get rid of that, we add 1. Same as what we would do if this were a normal inequality, inequation, anything like that. But when we do that, we have to do it to all 3 parts. So we're also going to add 1 to -2 and to 5. -2 plus 1 is -1. The 1's cancel out. In this middle part, we're left with -3k. And 5 plus 1 is 6. Okay, so now to get k by itself, we need to divide by -3. When we do that, we have to divide all 3 parts by -3. -1 divided by -3 is just a positive 1/3. And then careful with your signs here. We learned when we first started talking about inequalities, or I reminded you, you should have learned it a while back, but when you divide by a negative and you're working with an inequality, the sign flips. So since we're dividing by a negative here, both of our inequality signs are going to flip. The -3's cancel out and leave us with k. Flip this sign, so it's not less than anymore, it's greater than. And 6 divided by -3 is -2. Okay. We do need to rewrite this 3-part inequality. Now that we've got k by itself, that's what we wanted, but we need the symbols, the inequality symbols, to be less than, and we need these in the order that they appear on a number line. On a number line, -2 comes before 1/3. So the way that we rewrite this is -2 is less than or equal to k. is less than or equal to 1/3. So we've just switched the 1/3 and the -2, but when you do that, you have to make sure and flip the signs as well. Now we've got this written in the correct order, and we can graph our solution. Our graph of an inequality is just a number line. And we've got -2 and 1/3 that we need to mark on the number line. The way that you decide whether to use open circles or closed circles is by looking at the symbols. If you have this or equal to line, you're going to use a closed circle. So on -2 and on 1/3, we're using closed circles because we have this less than or equal to symbol. So we have closed circle at -2, closed circle at 1/3. And our solution, our variable can be any number in between those. So we shade the line between these two circles. So in a three-part inequality, you're not going to have an arrow pointing to positive or negative infinity. You're always going to be shading between the 2 points. Let's look at example 2. Solve 5 is less than 3x minus 4 is less than 9 and graph the solution set. Okay, so remember, we're focusing on this middle part, and we're trying to get the variable by itself. So we want to get rid of this -4 first. To get rid of a -4, we add 4. When we do that, we have to do it to all 3 parts of the inequality. Okay, 5 plus 4 is 9. These 4's cancel and leave us with 3x. And 9 plus 4 is 13. To get x by itself, we divide by 3. So divide all 3 parts by 3. 9 divided by 3 is 3. The 3's cancel out in the middle part. And 13 divided by 3 is going to give you a decimal. I would rather leave it as a fraction. And 13 over 3 can't be simplified, so it's just going to stay 13 over 3. Okay, this 3-part inequality is already in the correct order. So let's draw this, graph this on a number line. So we're going to have points at 3 and 13 over 3. And since these are strictly less than symbols, there's no or equal to line underneath them. That means we're using open circles at both 3 and 13 over 3. Open circle at 3, open circle at 13 over 3. And then we're always going to shade the line in between. Okay, three-part inequalities, it's that simple. The biggest mistake that I see made is when people try to work these, they, like from this first step, they might subtract 5 and like almost get rid of this part, but that's not how we want to do it. Focus on the variable and getting the variable by itself. And whatever you do it to all 3 parts. You're not trying to eliminate a part at any point. Okay, the next thing that we're going to look at is applications of linear inequalities. So we're going to look at some word problems, and to solve the word problems, instead of writing an equation, we're going to end up writing an inequality and then be able to solve the word problem using that inequality. Okay, so we're just going to do some examples of those. This will technically be example 3. We won't necessarily use a 3-part inequality to solve these word problems, but we will use inequalities rather than equations. Okay, so let me write this and then I'll give you guys a second to copy it. Okay, you guys take a second and copy this example down and then we'll work it together. Okay, let's read through this together. It says a rental company charges $15 to rent a chainsaw plus $2 per hour. Tom can spend no more than $35 to clear some logs from his yard. What is the maximum amount of time he can use the rented saw? Okay, so it says the rental company charges $15 no matter what, plus $2 per hour. So we could write that as 15 plus 2h, if h stands for the number of hours. So h is representing the number of hours that he uses the chainsaw. So it's going to cost him the $15 plus 2 times the number of hours that he uses the chainsaw. Then it tells us that he can spend no more than $35. So if this represents what he is going to spend, then this expression has to be less than or equal to $35. Because he can spend no more than $35, which means he can spend less than $35 or he can spend exactly $35, but not more than that. So what he's going to spend, the 15 plus 2h, has to be less than or equal to 35. And if we solve this inequality, that's going to tell us the number of hours that he can use the rented saw for the $35 that he doesn't want to spend over. Okay, so we've solved inequalities like this, just a normal two-part inequality. We want to get the h by itself, so subtract 15 from both sides. That leaves us with 2h is less than or equal to 20. Divide both sides by 2. That gets h by itself. H is less than or equal to 10. So what this tells us is Tom can use the rented saw for no more than 10 hours. He can use it for less than 10 hours. He can use it for exactly 10 hours. But if he goes over 10 hours, then he's going to go over his $35 limit. So there's our answer. Tom can use the saw for no more than 10 hours. We've got 2 more examples like this. So the next one will be example 4. Okay, you guys take a second, copy this example down. Okay, example 4 says a rental company charges $5 to rent a leaf blower plus $1.75 per hour. Mary can spend no more than $26 to blow leaves from her driveway and pool deck. What is the maximum amount of time she can use the rented leaf blower? Okay, this example is going to be set up exactly like example 3. So we're going to use H again to represent the number of hours. And the rental company charges $5 plus $1.75 per hour. So 5 plus 1.75H. And Mary can spend no more than $26. So this has to be less than or equal to 26. Okay, now we solve the inequality. So subtract 5 from both sides. 1.75H is less than or equal to 21. Divide both sides by 1.75. 21 divided by 1.75, you can do that in your calculator, you get 12. So this tells us Mary can use the leaf blower no more than 12 hours. Okay, let's look at example 5. Take a minute and copy example 5 down. Okay, example 5 says, Martha has scores of 88, 86, and 90 on her first 3 algebra tests. An average score of at least 90 will earn an A in the class. What possible scores on her 4th test will earn her an A average? Okay, so to find an average, you add up all the numbers and you divide by however many numbers you have. So if we were to find her average score, we would take her scores, 88 plus 86 plus 90. And then we know there's going to be a 4th test, but we don't know her score, so we just choose a variable. I'll just use X. So these are her 4 test scores. We just don't know the last one. And then to find her average, we would divide by 4. She wants to have an A in the class, and it says that a score of at least 90 will earn an A. So her average, what we've just written, has to be greater than or equal to 90 for her to have an A. Now we solve this inequality and try to find the value of X. Okay, let's get rid of this fraction by multiplying both sides by the denominator. So we're going to multiply both sides by 4 so that these 4s will cancel out. Okay, sorry. So we're getting rid of this 4 in the denominator by multiplying both sides by 4. So what we're left with on the left side of the inequality is 88 plus 86 plus 90 plus X. Let's go ahead and add up these first 3 numbers. So 88 plus 86 plus 90 is 264 plus X is greater than or equal to 90 times 4, which is 360. Okay, to get X by itself, we need to subtract 264 from both sides. So we get X is greater than or equal to 96. So we said X was what she needed to make on her fourth test, or what her score was going to be on her fourth test. So solving this inequality tells us that in order for her to end up with an A average, she needs to make at least a 96 or higher on her fourth test. So that's what we'll write as our answer. So Martha needs to make, you could say this a couple different ways. You could say she needs to make at least a 96. She needs to make a 96 or higher, however you want to say it. Martha needs to make at least a 96 on her fourth test to have an A in the class. So, like I said, you could say it a couple different ways. You could say that she needs to make a 96 or higher. What you couldn't say is that she needs to make a 96. Okay, that's true that she would end up with an A if she did make a 96, but that's not the only thing she could make. She could make a 96, 97, 98, anything 96 or higher. That would get her an A in the class. Any questions on these examples that we've done?